My name is Dr. Esther Trufan, and in this video, I am going to demonstrate a method that you can use to determine the density of water. For today's experiment, we're going to use deionized water, but you may use other water samples, and the process works the same way. Your density may be slightly different though. Because we're going to determine density as the result of these measurements, we need to collect both volume and mass data. For volume, we are going to use a 10 milliliter graduated cylinder. And for mass, we're going to use a digital scale with 2 decimal places. First, we're going to determine whether our scale works well, meaning it is calibrated appropriately or not. And we do this by conducting a set of measurements that will allow us to determine the precision of our scale. So we start with our graduated cylinder that is clean and dry, and we place it on the scale. We record the mass. It is 37.27 grams. We take it off. We wait for a little bit. We may even turn off our scale and restart. And then we place it on again. We find that our mass is 37.27 grams. So far, so good. It's rather consistent. We do this again. We take it off, wait a couple seconds, place it back on. And we find that our mass is 37.28 grams. So it is almost there, but because the scale is guessing that last digit, similarly to how we do with our volumes, sometimes it's guessing at 7 and sometimes 8. But because this is happening on the second decimal place, we can say that we can trust the scale to deliver rather precise measurements. We can set it aside for now. Next, we're going to pour approximately 7 milliliters of water into our graduated cylinder. The pouring amount doesn't need to be very accurate, but we will need to record the volume very accurately. We place ourselves eye level to the meniscus of our solution, and we find that the meniscus is between 7.0 and 7.1. Because the meniscus appears closer to the 7.1, we're going to estimate a number that starts with 7.0, and then we're going to add a second decimal place here that shows that it is closer to 7.1, but not quite there. So we're going to say 7.07 milliliters. We did a relatively okay estimate here. We're going to repeat this process again. But for now, let's try to forget about this number after we wrote it down. We take our graduated cylinder with the water inside, and then we're going to place it on the scale. We record the mass of the graduated cylinder with the water inside. In our case, it is 44.29 grams. The difference between the mass of the empty cylinder and the cylinder with water is going to give us the mass of the water. Okay, let's try this again. Looking away from the notes so that we may not subconsciously repeat our value, we record the volume of our water again, and then we record the mass of our water again. We lower ourselves close so that we can see the meniscus of our solution, and we find that it is between the 7.0 and the 7.1 markings. It is really close to the 7.1. So in our estimate, we want to represent that. We can say it is 7.09 milliliters. We record our second mass by placing our graduated cylinder and water on top of our scale, and we find that our second mass is 44.29 grams. We will then repeat our experiment at least one more time, and 3 measurements are usually satisfactory to determine whether our measurements for volume and mass are precise. And from the averages of these values, we can determine the density of water.